Hello everyone, I am Samiul. Today in this video I am going to revise the chapter matrix with you. That is important for CSIR-NET exam, GATE exam, JEST, TIFR, JAM exam, etc. Okay, so this is very basic chapter of our course, and this is very easy chapter also. Okay, you're not supposed to be to skip this chapter for your preparation for your upcoming exams. Okay, so first of all, what is matrix? Matrix is vector quantity, and you get one determinant for only for the square matrices. Okay, not for the rectangular matrix. Okay, and that means you only get for determinant for 2 cross 2, 3 cross 3, 5 cross 5. Okay, not for 3 cross 4, not for 3 cross 5, not for 6 cross 3. Okay, so always you will get the determinant only for square matrix. Okay, now where that is the form of n cross n, where n is the order of that square matrix. Okay, now here I listed few properties of determinant. So first property here, determinant of Ka, that is equals to k to the power n determinant of A, where k is a scalar quantity that is multiplied with the matrix. Okay, and k to the power n. Okay, n is the order of the matrix. Okay, now second property here, determinant of A, that is equals to determinant of A transpose. Okay, now determinant of AB, that is equals to determinant of A and determinant of multiplied by determinant of B. Now fourth property here, determinant of A to the power n, that is equals to determinant of A whole to the power n. Okay, number 5, determinant of A, that is equals to 0 for singular matrix, that means for linearly dependent. Determinant of A that not equals to 0, that is non-singular matrix, for linearly independent matrix. Okay, now determinant of A, that is equals to product of eigenvalues of the matrix. Okay, now what is the adjoint of matrix? Adjoint of matrix, that means the transpose of cofactor of any matrix. Okay, now inverse of matrix, A inverse, that is equals to adjoint A by determinant of A. Rank of matrix. What is rank of matrix? Rank of matrix is a number of linearly independent row or column is called the rank of the matrix. Okay, so if you have a matrix A and a determinant of A, if the determinant of A that is equals to 0, then rank of A must be less than n, where n is the order of the matrix, and determinant of A not equals to 0, then rank of A must be n. Okay, where n is the order of the matrix, and minimum rank of any matrix that can be 0, it is generally for the null matrix. Okay, so now how to find the eigenvalues of any matrix? Okay, first of all you need to know the Caley-Hamilton theorem, where if a to the power n plus a1, a to the power n minus 1 plus a2, a to the power n minus 2 plus dot 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 an, that is equals to 0, then lambda to the power n plus a1, lambda to the power n minus 1 plus a2, lambda to the power n minus 2 plus dot 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 an, that is equals to 0. Okay, here a1 is a trace of adjoint A always, and an that is equals to determinant of A always. Now for 2 cross 2 matrix, here the lambda square minus trace of A plus determinant of A. For 2 cross 2, you have 3 terms in that equation. Okay, for 3 cross 3, you have 4 terms, 1, 2, 3, 4. Okay, 4 terms in equation. Okay, so lambda square minus trace of A in alternate way, plus minus, then plus, then minus, plus minus, then again plus, then minus. Okay, so lambda square minus trace of A into lambda plus determinant of A, that is equals to 0 for 2 cross 2, and lambda cube minus trace of A into lambda square plus trace of adjoint A, you have to write here lambda. Okay, trace of adjoint A into lambda minus determinant of A, that is equals to 0 for 3 cross 3. Okay, now product of eigenvalues, that is the determinant of the matrix. Sum of eigenvalues, that means the trace of the matrix. Okay, now number 5, how to find the trace of adjoint A. if you have the lambda 1, lambda 2 and lambda 3 for 3 cross 3 matrices, then lambda 1, lambda 2 plus lambda 2, lambda 3 plus lambda 3, lambda 1 gives you the trace of adjoint A. Okay. For any triangular and diagonal matrices, its eigenvalues are its principal diagonal elements. Okay, its principal diagonal elements. Now, for rotational matrix, if you have odd order rotational matrix, that means 2n plus 1 order matrix, lambda equals to plus 1 for n plus 1 times and lambda equals to minus 1 for n times. And even order, that means 2n order matrix, you have lambda equals to plus 1 n times and lambda equals to minus 1 for n times. Okay. Lambda square is eigenvalue of a square. Lambda to the power k is eigenvalue of a to the power k, whereas e to the power lambda is eigenvalue of e to the power a. And sin lambda eigenvalue of sin a. Similarly, tan lambda eigenvalue of tan a. Okay, I hope you get the idea. Now, what is algebraic multiplicity? This topic is important for TIFR exam. Okay, so algebraic multiplicity is the number of repetition of each distinct eigenvalue. Okay, so suppose you have 3 cross 3 matrix and the eigenvalues are 1, 1 and 3. Okay, so algebraic multiplicity for 1, that is equals to 2. Okay, number of repetition of 1, that is 2. Okay, that number is the algebraic multiplicity. And 1, 1 and 3, the algebraic multiplicity for 3, there is no repetition, so algebraic multiplicity, that is equals to 1. Okay, and geometric multiplicity is defined as n minus rank of a minus lambda I. Okay, so this is the basic and this is the compulsory condition of algebraic and geometric multiplicity. 1 is less than equals to gm, less than equals to am. Okay, now what is similar matrices? So what are similar matrices? Okay, you have a and b matrix. A is equals to a Ijn cross n and b equals to b Ijn cross n are similar matrices if and only p inverse ap, that is equals to b, where p is non-singular matrices. Okay, and eigenvalues are similar. Eigenvalues are similar, not exactly same. Okay, eigenvalues are same for similar matrices. Okay, so if the eigenvalue same, then the trace should be same, then the determinant should be same. Okay, so eigenvalues are same for similar matrices. Okay, now what is diagonizable matrix? A is said to be diagonizable matrix if and only P inverse AP, that is equals to D, where D is a diagonal matrix. So A is similar to D. A and D are similar matrices. Okay, this is the first condition. Second condition is algebraic multiplicity, that is equals to geometric multiplicity. Okay, so for that the only condition is all the eigenvalues are different for diagonizable matrix. Okay, now idempotent matrix. Here I am going to discuss few special matrices. Okay, first idempotent matrix. A square, that is equals to A. Okay, this is the basic definition of idempotent matrix. We know that if lambda is an eigenvalue of A, then lambda square is the eigenvalue of A square. So lambda square, that is equals to lambda, and we can easily evaluate that lambda is equals to 0 and 1. Okay, so determinant of A can be 0 or 1. Trace of A, that is equals to rank of A for idempotent matrix. Okay, for involuntary matrix, the definition is A square, that is equals to I. Here A square, that is equals to A. This is the difference. A square, that is equals to I, and lambda square, that is equals to I. 1. For identity matrix, the eigenvalues that is 1. Okay, so lambda square, that is equals to 1, and lambda, that is equals to plus minus 1 for involuntary matrix, and determinant of A can be plus 1 or minus 1 for involuntary matrix. Nilpotent matrix. Okay, this is the definition. A to the power p, that is equals to 0. This is the definition of nilpotent matrix, and for this reason lambda to the power p, that is equals to 0, and lambda, that is equals to 0 p times. Okay, so determinant of A must be 0. Okay, nilpotent matrix never be diagonizable. Okay, because this if determinant lambda is 0 p times, okay, that means lambda is 0 p times, that means this is the, okay, look here, here why nilpotent matrix is never going to be diagonizable. Okay, you need to know, you need this relation, okay, am that is equals to gm, but for nilpotent matrix am that is equals to lambda to the power p that is equals to 0, that means am that is equals to p, okay, am that is equals to p for algebraic nilpotent matrix, but gm never be p for nilpotent matrix, okay, because this one is going to be less than n, okay, going to be less than n, because that is linearly dependent matrix, okay. Now for symmetric matrix, A that is equals to A transpose, this is the basic definition, okay, you need to remember this one. A that is equals to A transpose, A to the power P that is equals to 0, A square that is equals to I for involuntary, A square that is equals to A for idempotent, okay, remember this only, okay. So A that is equals to A transpose, that means Aij that is equals to Aji, these are the indices of matrices, and skew for a skew symmetric matrix, A that is equals to minus A transpose, Aij that is equals to minus Aji. Principal diagonal entries should be 0 for a skew symmetric matrix. For odd order matrices, determinant of A that is equals to 0, okay, that means 0 is an eigenvalue, okay, if the determinant is 0, that means 0 is an eigenvalue of odd order skew symmetric matrix, okay. Now A that is equals to A dragger, this is the basic definition of Hermitian matrix. What is A dragger? A dragger is nothing but A transpose, then the A conjugate, or you can write it as A conjugate, then the A transpose, okay. So for Hermitian matrices, diagonal entries are real, okay, eigenvalues are real for Hermitian matrix, okay, remember this, okay. Many times question asked from this portion, what are the eigenvalues of Hermitian matrix, what are the eigenvalues of skew symmetric matrix, skew Hermitian matrix, okay, question frequently asked from here, okay. So remember this, what may be the eigenvalue of Hermitian matrix, what may be the eigenvalue of skew symmetric matrix, skew Hermitian matrix, okay. So eigenvalues are real for Hermitian matrix, every real symmetric matrix are Hermitian. For skew symmetric skew Hermitian matrix, A equals to minus A dragger, and diagonal entries are either 0 or purely imaginary for skew Hermitian matrix. Eigenvalues are both the eigenvalues are either 0 or purely imaginary or both, okay, for skew Hermitian matrix. Every real skew symmetric matrix are skew Hermitian, okay. Now what are the condition, what is the condition for orthogonal matrix? A that is equals to A transpose that is equals to I, or you can write it as A transpose A, that is also I, okay. Here A inverse that is A transpose, so determinant of A never be 0. So if determinant of A not equals to 0, none of the eigenvalues are 0, okay. Now for unitary matrix, A dragger that is equals to I, this is the basic definition, A dragger that is equals to I that is equals to A dragger A. So A inverse that is equals to A dragger, and here A that is equals to 1 for all eigen here for unitary matrix, A determinant of A that is equals to 1, okay. So all eigenvalues are of unit modulus, that is lambda, the modulus of lambda that is equals to 1, okay, and therefore none of the eigenvalues are 0, okay, because determinant of A is 1, so none of the eigenvalues are 0. Now special unitary matrix. So for special unitary matrix, this is the form of a special unitary matrix: alpha minus beta, here beta, and here alpha bar. This is the complex conjugate of alpha, and alpha beta belongs to complex plane, and here alpha is mod of alpha square plus mod of beta square, that is equals to 1. This is the basic condition for a special unitary matrix. So this is it. This is the end. Okay, so if you prepare these portions, this this is the question frequently asked from inverse of a matrix. This is asked in GATE exam. Okay, generally. Okay, rank of matrix, this is also asked in GATE exam. Okay, eigenvalues of matrix asked in everywhere. CSIR-NET, GATE, TIFR, JEST, everywhere. Okay, now this is asked in TIFR and JEST, etc. Okay, similar matrix, Diagonizable matrix, and this portion is very much important for CSIR-NET exam. Okay, so prepare this one, and if you have any problem, any query, then comment below in the comment section, and you can tell me which portion, which topic from this video you want to learn from me. Okay, so if you don't subscribe my channel till now, then do it first. Okay, if you like my videos, then share it with your friends, and share it. Okay, and press the like button. Okay, also, thank you.